All right. So I was playing around with the A value for quadratic functions, and I wanted to see how could I graph using the A value. And so I did some experimentation. I started with this A equals 1, and I noticed from the vertex, I actually, let me make this a little bit, there you go. Vertex, I went up 1 over 1. All right, what happens if I go to a 2? There's 3. 2, I went up 2 over 1. So right now it feels just like it would say if it was a line. And so A value of 3, I went up 3 over 1. So with whole numbers, that works. If I put a negative in front of it, now I'm going, again, down 1, 2, 3, and over 1. Same thing with 2. I went down 1, 2, and then over 1. And so right here, I have this thing. So when I have it, I go up 1 over 1, up 2 over 1, up 3 over 1. Here I'm going down 1 over 1, down 2 over 1, and down 3 over 1. So I literally can treat it just like I can the M value for slope in a line. But then what happens when I do fractions? Because fractions don't work that way. So here I'm going to put a 1/2, and you'll notice it did not go up 1. Oh, let me do this again here. It did not go up 1 over 2. That did not work. And so what did it do? From the vertex to its next point up here, it went up 2 over 2. All right, so what happens if I put a 1/3 in there? And 1/3, if I kind of take this line to my next point, goes over here. And so I notice that is an up 3 over 3. Well, what do you think the fourth would do? Same thing, up 4 over 4. Well, let's look at this. I follow this line. It did go here, which is up 1 over 2, but how do I look at that with the 1/4? But my next point is right here, and sure enough, that is up 4 over 4. So if the fraction starts with a 1 and ends with a number, then that denominator, it goes up that amount and over that amount. And so I'm going to go over here. I'm going to start filling this out. It went up 2 over 2. The third one up 3 over 3. The fourth one, 1/4 one, up 4 over 4. So I thought, okay, what happens though if the top number is not a 1? So let's try 2/3, 3/4, and 7/4. So I come back over here and I do this 2/3. All right. So as I'm looking here and I follow the line until it gets, I can't. I'm going to have to, there we go, right here at this spot. And it went up 6 over 3 for 2/3. So 2/3 was up 6 and over 3. All right, 3/4. We'll put a 3/4. And let's make this a little bit bigger so we can see what's going on here. And if you look right here, I believe, yep, 4/12. So it went up 12 and over 4. Up 12 and over 4. So let's go over here and put this one up 12 and over 4. And let's do one more, put 7/4 here and see what happens. And what you'll find is, let's see, there we go. And if I follow my 4, because that's kind of what I'm expecting, right here is at the 428. So it literally went up 28 and over 4. So let me go back over here, up 28 and over 4. So my next thought is, well, how did we get the 6? How did we get the 12? How did we get the 28? And I went, look at this. 2 times 3 is 6. 3 times 4 is 12. 7 times 4 is 28. So to get how far up you go, you just multiply the two numbers. Now, granted, if you're going down negative 2/3, it would be a negative 6, and you would go down 6. So here's my conclusion. This is what I've learned. Look at your A value as a fraction, numerator over denominator. multiply the numerator and denominator, and that's how far up you're going to go for the vertex. Or if it's negative, that's how far down you're going to go. And then your denominator, your d, is how far you're going to go. Left or right, it doesn't matter because we're going to have symmetrical points. So both ways. So here are 3 examples. A 3 as a fraction would be 3 over 1. So multiply them. N times d, 3 times 1 means it goes up 3. And then the d equals 1 makes it go over 1. 1/2, what's 1 times 2? 2, so it goes up 2. And then what's the denominator? 2, so it goes over 2. And then 7/4, what's 7 times 4? That's 28, so it's going to go up 28. And then the d value being 4 means it's going to go over 4. That'll work every single time. All right, go have some fun with that.